Welcome to this lesson. We are doing trigonometry grade 12 and we are dealing with cos compound and sine compound, the compound angles. Now this is part 4 and I call it the boss problem because it is not straightforward. Everything is not given to you. For example, let's check the pattern that our trig ratios form. We have cos, sine, cos. Again, we have cos, sine, cos. This pattern doesn't match up with the cos compound or the sine compound. What about the angles? We have 65, 295, 115, 205. All of them don't correspond. They don't match up. So we need to reduce them. The angles that we use to reduce bigger angles are 90, 180 degrees and 360 degrees. Now usually when you reduce angles, you usually start with the bigger ones like 295 and 205. Do you remember the Coco rule, where if you have sine of 90 degrees it will change into cos, and if you have cos of 90 degrees it will change into sine? Well, since our trig ratios don't form a pattern that represents the pattern of sine or cos, you have cos, sine, cos. One of the trig ratios in either side needs to change, and the only way to change a trig ratio into another trig ratio is through the Coco rule, meaning we need to reduce using an angle of 90 degrees at some point. What about this angle, 115? What would happen if you reduce it using 180? Let's see, you have 180 minus 115. You get 65. Now we can leave this as 65 so that it matches up with this one. This is what you need to be thinking at this stage before you solve, because anything that you do after this will determine your answer. And no matter what you do, if you change something on this side, it needs to correspond with what you have on this side. So sometimes changing something on this side will cause you to do more changes, and the process would continue on and on until you get frustrated and quit looking for the final answer. So let's do whatever we can do. What about this angle, 205? Since I have talked about a lot of steps that we need to take, I have decided that we should take one step at a time. So let's reduce sine of 115 first. We have cos of 65 degrees multiplied by cos of 295 degrees minus sine of 180 degrees minus 65 degrees multiplied by cos of 205 degrees. We will have cos of 65 degrees multiplied by cos of 295 degrees minus 180 minus, that's the second quadrant, and sine is positive, so positive multiplied by negative will give you a negative. So we will have sine of 65 degrees multiplied by cos of 205 degrees. Now we have two angles that match up. We have 65 degrees and 65 degrees. But then our pattern is still messed up. We have cos, sine, cos. This doesn't resemble sine compound. This doesn't also resemble cos compound. What do we need to do now? If we use 90 degrees to reduce 65, we will have sine of 25 on this side, and on this side we will have cos 25. So we will have sine, cos. That would still make no sense. So what do we need to do now? 295 and 205. How about we use 360 to reduce these angles? Let's start off with this one. I have 360 minus 295. We get 65 degrees again. Wow, this is surprising. If we reduce this, we will eventually have cos of 65 degrees. So we will have cos 65 multiplied by cos 65. That has never happened before. That's something we have never seen before lately, right? And on this side, what about 205? Let's reduce 205 by 180. 205 minus 180, we get 25. Let's use 360 minus 205. 155. See, this is where things get way more frustrating, and time is running out in the exam, so we need to think fast. What do we do? If we reduce 205 by 180, we get 25, right? But we can still use 25. We can still use 90 degrees on 25. 90 minus 25, we get 65. So what I'm seeing here is we need to have 65 here, 65 and 65. And since we're going to use 90 degrees to reduce 155, this cos is going to change into sine. So we will have cos, cos, sine, sine. Finally, we got it. Let's do it. We have cos of 65 degrees multiplied by cos of, we are going to use 360 degrees minus 360 minus 295, we get 65, minus sine of 65 degrees multiplied by cos of 180 degrees plus 205 minus 180, get 25 plus 25 degrees. So we have cos of 65 degrees multiplied by cos of 360 minus, that's the fourth quadrant, and cos is positive, so we'll have cos of 65 degrees minus sine of 65 degrees multiplied by cos of 180 plus, that's the third quadrant, and tangent is the only trig ratio that is positive, so we will have negative cos of 25 degrees. So we have cos of 65 degrees multiplied by cos of 65 degrees. We have this negative sign multiplying with this negative sign, so we will have positive sine 65 degrees multiplied by cos 25. Now I am already reducing 25 using 90, so we will have 90 degrees minus 65 degrees. This is equal to 25. So let's continue. We have cos of 65 degrees multiplied by cos of 65 degrees plus sine of 65 degrees multiplied by, now since this is 90, it will cause us to apply the Coco rule where cos will change into sine. So 90 minus, that's the first quadrant, so all trig ratios are positive in the first quadrant, so we will have sine of 65 degrees. Wow, nobody expected this. This is the boss problem. I told you. We have cos 65, sine 65, sine 65. This is the cos, sine, sine. This is the cos compound, but we have A as our angles. But let's apply it. We have cos of 65 degrees. Now, since this is the cos compound, the sign changes into minus 65 degrees. Now, this is where people panic, because you're going to get cos of 0, and it looks totally wrong, 0 degrees. But I don't know if 0 is a special angle, but I know that there's nothing wrong with this. So the answer that we get is 1. Now this looks wrong, right? So you're not sure whether or not your answer is correct. So we need to check it. How do we check it? We put the whole thing into our calculator. Cos of 65 multiplied by cos of 295 minus sine of 115 multiplied by cos of 205 degrees. So this is correct. How many marks are these? Maybe 4 or 5, I don't know. but I didn't. You see, in the exam they say 5 marks is equivalent to 5 minutes, but I didn't spend 5 minutes doing this, man. It wasn't easy. Sometimes, you know, you do a lot of work and you have limited time. Anyways, man, thank you for watching. See you on the next video.